Hello. I'm Prabha Iyer and the beautiful Sarah over there at the back. We are the two newest humans to join the Indiaspora team. And I'm here to introduce the next speaker. And there's something compelling about him I want to share. Even with his very demanding job and lots of speaking engagements, he took the time on a weekday to come and support a nonprofit. And that's where I met him. And today he's here to support another nonprofit. Please join me in welcoming Manohar Paluri.
Thank you everyone for having me here. It's pleasure to be here, first of all, on a Friday evening. So I appreciate you all supporting all the initiatives. It's always an honor to be in nonprofit. I was deeply impressed by the set of talks and the intelligence that everybody parsed the current wave of Gen AI that we are all going through in the panel, as well as the couple of other talks. So what I wanted to talk today is the latest release that we had with Llama 3. I'm Manohar Paluri. I'm a VP of AI. I lead all of the engineering and research for Gen AI at Meta. My journey at Meta started 11 years ago, and my journey in AI started 19 years ago. So when somebody was talking about AI is something we're trying to achieve, and when we achieve it, the puck keeps moving. It's kind of the life story, which is probably why I got into AI. I wanted to work for life. So if you go to the next slide. So what I wanted to quickly talk about is Llama, which is a very cute name for a foundation model. It's basically our effort in building intelligence into the large language model and making it available to the world. And there's multiple reasons why we want to do that. First and foremost, we believe that the current wave of progress in AI is not going to get us towards singularity. It's going to take us multiple decades to keep pushing the frontiers. And the best way to push the limits is to do it openly, is to do it with everybody. The number of engineers and researchers that Meta can have is never going to be enough for us to make the progress in AI. So we launched Llama first with a research license because we thought it's not going to be as useful. This was in 2023, and the amount of overwhelming response we got was crazy, especially from a community like this and many of the startups. So we actually followed it up with Llama 2, which was supposed to be a flip of a bit in license, and we wanted to make it from research to commercial. This was a fun story. What we thought was going and editing a text file became Llama 2. And when we launched Llama 2, it was the best open model available, while many other models were hosted behind an API. And Llama 2, to give you a sense, there are roughly 170 million downloads of Llama 2 since we released it. That number is staggering. Now, when you have success like that, you have to work hard. And that's how Llama 3 is born. And last week, we actually launched Llama 3. Between Llama 2 and Llama 3, we saw a tremendous increase in need of coding applications where people wanted to use these foundation models to actually have automated code generation. So that's Code Llama. The timeline of Llama is pretty interesting to me because of the acceleration of the technology. So before I go into the details of Llama 3, the best Llama 2 model was a 70 billion parameter model. And the smallest Llama 3 model actually compares to the strongest Llama 2 model. That is the acceleration of technology that we are in right now. So with Llama 3, what we launched is two models, 8 billion and 70 billion. The difference in the technology that went between Llama 2 and Llama 3 is we actually compressed 7 times more knowledge into the foundation model. We had more than 10 million instructions to the model on how to behave for various queries, and it achieves state-of-the-art performance compared to any other model on that capacity. So the 8 billion model is better than any other 8 billion model that is freely available, and the 70 billion model is better than any other 70 billion model that is freely available. These are the stats. If you look at how to measure these foundation models, there are high-level 5 categories: the general knowledge that this model is compressing into, the ability to understand and reason with math, code, ability to read, so it can actually do creative writing, and a few other tasks like that. If you look at Llama 3's performance, we have achieved state-of-the-art across all of these benchmarks. Typically, when you build these models, it's easy to compress a particular kind of knowledge into these models, so you are doing better on history or economics or math, but to actually do it in one model where it's giving you state-of-the-art performance on all the tasks, that's actually something that is very challenging. So one of the other ways to qualitatively compare whether this model is good is human evaluations. So we asked a user to take any prompt that they want and compare Llama 3 to Llama 2 and many other models that are proprietary. And you can see that Llama 3 models consistently outperform all the proprietary models as well as our previous iteration. There is an I don't have it in the slide, but there is a evaluation leaderboard called LMSys where anybody can go and test any model. It's blind test. We were very heartened to see after a release within 3 days, Llama 3 basically is on par or slightly below GPT-4, which is the only other proprietary model in this blind test, beating Cloud Opus, which is the largest model from Anthropic. That is pretty remarkable, and we didn't anticipate that. So it's the crowd that is speaking for Llama. We also talked a little bit about our largest model with Llama 3, the 400 billion model. This is still training. Llamas are still cooking as we speak. They're still grazing. What we saw is we took a snapshot as the model is training, and we saw on various benchmarks how this model is performing. And it is starting to compare to the best proprietary models out there, one of them being GPT-4. Now, the development of these models is pretty tricky. It takes months. It takes clusters of many of the H100 and many other kinds of hardware that you probably, each company uses different kinds of them, but NVIDIA is the predominant one. You train the model, that is the base model, you instruct tune it, but the more important thing is to get the model to be helpful and also safe. And when you're a company that is actually building it for the products, but also open sourcing it so everyone else can build it, you have to find that balance. What we did with Llama 2 was the safest model possible. So if you ask it a question, how do I kill a margarita? It'll basically say, how do I make a killer margarita? What you actually mean is an awesome margarita. But the model will say, I am an ethical AI. I cannot encourage you to kill, which is very annoying for a system to do. With Llama 3, it'll basically understand the nuance, and it'll give you a very clear answer. And if you're actually crossing a border on safety, it'll still try and give you both sides of the opinion, which is very hard to get. So finding that real nuance between helpfulness, the Goldilocks is what we were able to achieve with Llama 3. So the reason we wanted to open source Llama in the beginning was the pull from everybody to build on top of a foundation model. But the ecosystem that got built on Llama basically made my job harder. And what we noticed is Llama was penetrating all the way from hardware to the ecosystem on the top, with cloud providers giving it at much reduced cost, because we actually don't charge for Llama. It's free, it's commercially available. And the developers that were building on top of it, including many famous names that you probably heard. And the developer ecosystem organically manifested. To give you a sense of it, the Llama team that I managed when we actually first launched Llama was 7 people. And that became a team of 40 people with Llama 2. And we are now still a small team of 120 people, much smaller than any other foundation model team that exists out there. Now, the reason we wanted to do open sourcing of Llama is, as I said, to accelerate innovation in AI, to make it an even playing field for everybody wanting to use these models for various applications. And 3, there's a tremendous amount of work that needs to go in making these models safe and using it in various use cases across the world, whether it's multilinguality, multimodality, using it in cases where you have to be very particular about the Adalat.ai. How do you make sure it's fair, it's not biased? How do you make sure that it's actually able to understand all the languages that it's serving? You can only do that using an open approach and modular approach. In this particular use case, what you see is the LLM model in the center, but on in the input and the output, you actually build more advanced models that can understand the nuance of the input and understand the nuance of the output. So you don't have to change the model in the center, which is harder to steer. You use these input-output classifiers to actually see if the model should answer a particular question in what kind of style and so on and so forth. So you can put age gating, you can put cultural gates and so on without ever modifying the model. This is called Llama Guard. This is also open source. So any developer can use Llama and the Llama Guard to actually build a safe system that can work for everybody. We also deployed Code Shield. It's not unheard of for many of the junior program developers these days to copy paste code from the outputs of generative models. How do you make sure that the code that is generated is actually safe? So Code Shield actually allows you to run all of the code that is generated through Code Shield and make sure that you don't have injections and many other safety constraints, safety issues. Finally, these models need to be steered for your use cases. Adding a new language for Adalat.ai, whether it's in India, going and basically making it work for healthcare. These are things that you will have to do. So we also introduced TorchTune, which is a library on top of PyTorch, which is one of the most used frameworks for AI, to tune the models of Llama so it can work for you. It's your Llama. There are many resources that you can look into, and what is coming ahead is super exciting to me. One of the things that I'm excited about is not just the big model, but also the multilingual. This is going to make a huge difference because it's free, openly available, and I'm super excited that many of the languages that we're prioritizing are for India as well. So this community will benefit a lot, and I'm very proud of it, and I want to make it a reality. Multimodal, many of the free models don't do multimodal. One of the big advantages of Meta is our ability to build multimodal that is state of the art is top notch, and that is something that everybody will get. And finally, safety. You don't want to deploy these models without understanding the nuances of it, and that's where Code Llama, Safety, Llama Guard, and all of these come together in a package. So you can experience Llama, not as a developer, but also as a consumer in Meta.ai website. And you can actually download Llama and see the technical report that we produced on this link. Finally, one of the things that I'm more excited about is these generative models actually understanding our world. So here what you see is an example of set of videos that Llama is able to create as you give queries. And this is something that unlocks your imagination. So I'm imagining a world where you're not interacting with machines using text and looking at text. I know there are a lot of generative images and generative video technologies out there, but the future will be a conversational agentic capabilities that is going to be multimodal in and multimodal out. And that is what we are going towards Llama. And not only that, we are actually changing the way people interact with these generative models. Here you see real-time generation as you type the query that you can actually, everybody can now imagine. This is my favorite kids storytelling exercise that we do at night, where before the bed, we actually real-time create things, imagine things, and they are mind blown with the technology. They think I'm actually retrieving the photo from somewhere, but the machine is actually generating the query. Thank you.
Talk a bit about, so from release to release, when you come up with a new release, kind of what's the general experience with the model doing things that you weren't quite expecting, meaning having more functionality than you anticipated? What does that surprise feel like? How do you guys process it internally? And then try to kind of understand what caused that. So I just want to understand, what if this feels deterministic, right, from a release perspective? And what if it feels like, oh, wow, let's try to understand why that happened.
Yeah. I'll give you, so from each release, we have some emerging properties and we have some properties that we expect it to get better. The predictable ones are knowledge. Does it get the knowledge part right, where it's able to remember history properly, it's able to get certain equations right, it's able to generate code better, and so on. But the unpredictable ones are pretty cool. So for example, my son is 5-year-old. We do some small riddles here and there to increase his creativity and ability to reason. Llama 2 would not get some reasoning questions. Llama 3 starts beating some reasoning questions with respect to my 5-year-old. So those are some emerging properties. In multimodal, there are some things like memes. I'm actually reasonably acquainted with memes, but there are certain memes that you have to reason through because you have to know the cultural setting of it. So if you look at a photo of a person reading a particular book and you ask what is so funny about it, it turns out they're reading a book of Hawaii with Hawaiian food on the table. That is something that I couldn't get, but these models start getting. So they start mixing the textual as well as multimodal and cultural aspects in a way that's not possible for a single human to do. So these are some emerging capabilities. And with video and 3D and many of the behaviors of behavior mimicking and imitation learning, I think these emerging capabilities are going to increase more and more.
Okay. Quick question on small language models. What is your view on how that is evolving? And another question around energy footprint of foundation models. Our brain has been the most efficient in terms of performing these tasks. Do you think foundation models will ever get there with the transformer architecture?
I'll take the second question because it's easy. I don't think so. Because again, we keep pushing the bar on what we believe is AI, and that's probably, and I have been through the revolution of SIFT and ORB and GIST and all of those handcrafted features, then moved into deep learning with ConNets, then moved into BERT and transformer architectures, and the scale of what we have been doing has been growing forever. So my honest answer is it doesn't feel like, to me, we are converging to a particular IQ of these models, and it's not clear to me that we'll surpass it. I'm here for a positive surprise. We'll see. On the first one, I have seen time and again performance and efficiency alternate themselves in cycles. So what I have noticed is when you build a model that works, there are some emerging capabilities that you were not able to do before. And then the efficiency cycle kicks in, whether it's the hardware vendors that get us there or quantization techniques and distillation techniques and many other techniques. So very rarely have I seen efficiency work surpass in performance ever. So I feel that's one of the conversations that I always have with the leadership at Meta, including Mark. It's like, we'll have to burn a lot more to get to the next level, and then we'll find a way to efficiently serve it to 1 billion people. And that has been the, at least in my 11 years of whatever I've done, and probably many, many years of everybody who has worked in AI, that cycle, I think, has been consistent.
Question here. That's right. So I'm a big user, tester of Llama, love it, but that doesn't really perform as well because we're in the enterprise with private data. So do you see RAG-like system architecture coming out of Llama that we could potentially use it really well in healthcare? And I'm also involved in public health too, so there's also sort of an external side to it, which is why I'm here. So.
Yeah, so two parts to that question. One, absolutely. Actually, you will see as Llama 3 release that happened last week was a preview release. The actual release will be a cadence of releases that you'll see in the coming months, one of which will address your question. The second one is, the part of the open source strategy is exactly that, which is we want to understand where these models do well and unlock the benefit. Going back to the power usage of these models. If everybody has to train this foundation model, imagine the cost on the planet. That doesn't seem right. So that's one. Second, we also want to know where these models don't work. And when you, what we saw after Llama 3 release in the first 3 days, we had somebody build a 128K context window model. We had somebody build a web browser on top of 8B model. We had somebody actually do a multilingual version of it in the first 3 days. So over the next few weeks, I'm expecting a lot more contributions from the developer community than what we can do, but our future releases are going to tackle some of the things that you're talking about. Yeah, this is a great question. I mean, one of the things that I didn't go deep into is the safety. We had an intuition 2 years ago that these models are not just good generative models, but they're also, essentially what is happening under the hood is they're learning the distribution of the data. And when you learn the distribution of the data and you go and edit it in some way that you want to tamper, whether it's creating deepfakes or not, the same models are actually better at detecting. So it turns out you're in a virtuous cycle where you build a better generative model, it does better reasoning. So, and better reasoning allows you to do better generation. So we are actually in that very virtuous cycle. And I think in Adalat.ai, there was a very good point that somebody made, that the speaker made, which is every time you make a mistake, that particular mistake correction is the highest value for the next iteration. And when you do that, so every deepfake detection, in fact, most of these models are able to beat humans with respect to even text tampering. So the watermarks that we put in on text generation, most of the humans cannot even pick it up, but the models pick it up.